Hi guys, Mrs. Rathe here. Today what we are going to do is take a look at how the website Graspable Math can be used to help show work for a coordinate proof. To get there, we type in graspablememath.com. It brings us to this website. We are going to explore algebra, and we get to this nice blank canvas. Graspable Math is a website that allows us to transform expressions. So we're going to make it do the proof for us. And I like to do the whole proof in here and have all of my work in one nice screen. So what I'm going to start by doing is insert text. And the proof that I have is a proof where we have been given A is at 1, 1, B is at 4, 4, and C is at 6, 2. And I want to prove that it is scaling. So I have the text, I just have it hanging out there. Now I don't like where it's positioned, so I'm going to click arrange. I'm going to drag it to the top left corner. Not necessary, but I like things tidy. So to prove it's scaling, I know that I need to get the length of 3 sides. So I'm going to insert an expression. The first expression I need to do is the length of AB. So I type AB equals the square root of, and now I'm going to do the distance formula. 1 minus 4 squared plus 1 minus 4 squared. And to type this in, you can use your keyboard, which is what I am doing, or you can press the buttons down here. Both work. There's AB. The really cool thing, this is going to do the calculations. So the first thing I would do is subtract. So I click on this minus sign. It subtracts for me. Then I would subtract here. Then I would square this. And then I would keep squaring. So as you click, it does the calculations. Now AB is radical 18. That's the number I needed. I told you that this would help you show work. If you hover over that radical 18, some white dots appear. If you click on those and you drag down, it shows you all of the calculations that you did. Now I'm going to click smaller up here so that I can see it all. Now, I probably wouldn't show all of those steps. So you can actually drag up and down and show as many or as few as you'd like. So like for me, I kind of like this path. These 4 steps show that I clearly understand how to calculate the length of AB. So then I'm going to insert another expression and do the same thing for BC. Oops, it's not absolute value. And get that length. So BC is 4 minus 6 squared plus 4 minus 2 squared. We click done, and we're just going to click away and allow it to evaluate that expression for us. And then we'll use our white dot to drag down to show an appropriate amount of work to calculate what BC equals. So, and it's up to you. You could show every single step. I just like to tidy mine up a little bit and not show every single step necessarily, and personal preference. We'll leave that one with all of the steps shown. So then I don't like how that's hanging out way down there, so I'm going to click on arrange. I'm going to drag it up here so that these are next to each other. This is just a me thing. I like things to look nice and tidy. I'm going to insert one more expression and calculate AC. AC is the square root of 1 minus 6 squared plus 1 minus 2 squared. Done. We're going to click, click, click until we have this evaluated. Radical 26 is AC. I have 3 sides. This is enough to convince me that this triangle is in fact scaling. So I'm going to arrange. I like to have these all next to each other. So I have all of the work right now that justifies that this is scaling. To turn it into a proof, we would need to write a conclusion at the end. You can do that in Kami, Go Formative, wherever you're doing your assignment, or you can actually insert text here and type it down at the bottom. So we could say a scalene triangle is a triangle with no congruent sides, therefore triangle ABC is scalene, and wrap up the proof here. Now, once you have the full proof nice and pretty in this Graspable Math, you could do a capture screen and insert that image into Go Formative or whatever platform you're using to show your work for your teacher. So just a review on how to do that. The students with the new touch screens on the bottom right corner, you would click on your pen, drag a box, capture the region, save it, insert it. Students without that, or if you prefer this method, Control Shift change window, drag a box, capture it. If you need help with that, that's something that you should ask for if you need help capturing the region, but it's a really cool tool. In this, you can actually also insert graphs. If you click on graphing, it might take a second for this to load, but it embeds a GeoGebra. So we've looked at using GeoGebra, and you could actually use this. Mine is it's gonna drive me crazy. I have to drag this off to the side so I can see it a little bit better. But you can actually tell GeoGebra A is at 1, 1. A equals 1, 1. It plots it for you, so you could include the picture of the graph. When we get to lines, you can have the line embedded here, so you can really do a nice, pretty graph all inside of Graspable. It'll do slope for you in a similar way. So please check this out. Use it as a tool if you like it as a resource for showing work.